quiz or something.
This is a long time.
What?
How long was your plan?
Trying to get out of class, you guys pulled me back in. So, what are we doing today?
So you should have done that the day before Thanksgiving.
Number 5 on the set of 20 problems.
Yeah, Thomas, he's not reading that.
No way.
That's fair.
We wrote some good stuff. You want to know how you make an actual classic phone case?
I literally printed out all this and I didn't even do any of it. So then
Number
just
5.
practicing
On the
like
on the big one, the randos?
Yeah, the big one.
Those are hard, the 3x3.
Yeah, that's why we want that. We tried to do all three.
So you don't need to know that. So that's a 3x3 Markov.
Wait, we don't need to know that?
No.
What
Not
do we
one.
need? What do we need?
Oh.
Let's start there now.
Yeah, let's start with
As
the.
far as Markov things go,
Can you make like a study guide for us right now?
make a study guide for the study guide.
Like a more in-depth one?
So for the 2x2 case, you need to know how to fully flesh out a calculation.
What does that mean?
It means draw transition diagrams. It means you should know how to set up a transition matrix. It means you need to know how to find a state matrix. You need to know how to find S bar and P bar. And of course, in general, just answer word problems. For the 3x3 cases, I'm not going to ask you to do this stuff because that's going to take forever. You want to know conceptual problems. As in, identify like an absorbing state. Is it an absorbing chain? Absorbing chain. And talk about something like does the stationary matrix exist? That kind of thing. So if it's larger than a 2x2, I'll ask you conceptual stuff.
Wait, how do you know if the stationary matrix exists?
Some power of P has to have non-zero entries. So pretty much if I give you something and it's already, everyone has positive numbers everywhere, then a stationary matrix will exist.
Wait, some power P what?
Come again?
Like, how do you know if it doesn't exist?
Like, we had a theorem for when it exists. It means if P to the K has only positive entries for some K. So if I give you P and there are no zeros anywhere, or I somehow give you information that leads you to believe that there's a power of P that has no zeros anywhere, then the stationary matrix will exist. So in terms of 3x3 matrices and actually doing like computational stuff with them, you don't have to worry about that until the final. So I wouldn't completely forget about it, but you don't need to know it for a fact.
We know which is
The transition diagrams, that's just like the circles.
Yeah, that's like, you should know how to plot one of those things and talk about, write the numbers on it, that kind of thing. And the transition matrix is the P matrix, and then you should be able to find all the SN matrices. And also find this stationary matrix and the limiting value of the transition matrix. And it'll either tell you that, hey, find the stationary matrix, or it will ask you a question like, what if this happens for a long time, or far into the future, what can we expect? It's asking for these guys. That's what you should know. So that, just like problem 6. So like problem 6 is a good example.
then we do all
So
that.
problem 6 or similar, like a problem like that, I would put on the test.
Probably not.
Is it 8 questions again?
A problem like
Yeah, but
6?
it'll be the same,
6 on
8 or
one.
9, something like that, about an hour long,
Wait, 6 on each.
about 50 minutes.
What do we need to know for like counting and probability?
I'm not gonna ask you anything directly related to counting, so you just need to know how to count good enough to do the probability problems.
And like what kind of probability problems do we do?
What, like the stuff in the revisions. And you should know, of course, you should know things like Bayes' theorem, like general ideas for probability, know about conditionals, know what makes something independent versus mutually exclusive, things of that sort. And know how to actually show that via calculations. So if I ask you, oh, are these two events independent? You can't like write a paragraph to me explaining why you feel they're independent. No, you need to show me an equation. You need to show me that, what would you need to show? If A and B are independent, what does that mean in terms of equations? Yeah.
Isn't the probability of A given B equal to the probability of B? Or is
A. There's another equation. So if you happen to be in a situation where you know the conditional, that's the equation you would check. There's another equation to check.
P A and B is equal to P of A times P of B.
Right, where the and probability is just the multiplication. So if I ask you, are these independent? And you tell me yes, what you need to show me is one of these two equations is true. Yeah.
What does that mean for everything being independent? Is it always multiplying?
It's not always. So this is not true in general. Yeah.
For mutually exclusive though, is that just if P of A?
Mutually exclusive means they cannot happen at the same time, which means that the and is 0. So A, B, mutually exclusive. The two equations that you want to check is that the probability of A and B must be 0. So if I tell you the probability of this and that happening is 15%, are they mutually exclusive? Obviously not, because you just told me it was 15% and not 0. Another way is the OR is the sum of probabilities, which is not true in general. In general, we would, the equation in general for the OR is what?
P of A plus P of B minus P of A and B.
Right, so that is true in general. This is true in all cases. However, if you are mutually exclusive, your P of A and B is 0, so this part is 0, and you just get the OR is the sum. And if it's independent, the AND is the product. Or the conditional actually doesn't matter what happened first. So things like that. So if I ask you, is it independent? And you say yes or no, you either have to tell me this equation works or no, it doesn't work. So things like that you should know. Bayes' theorem you should know, which again, the hint that you want to use Bayes' theorem is if you know a conditional but you're asked for the conditional in the opposite order. That way you should think of Bayes' theorem. Another way you can think of Bayes' theorem, which is a very common type of problem, is like that coin problem. So do that coin problem. Or something similar, coin problem. Or similar. So it's like when you had some fair and some were unfair, and you pick a random one. And then ask you, what is the probability of heads, or something like that. You know, so situations like that is also something where you use Bayes' theorem, version 1. So you'd say the probability of getting heads, for example, is the probability of getting heads given that I chose the fair coin times the probability of choosing the fair coin plus the probability that I got heads given that I got an unfair coin and probability of choosing the unfair coin. So that's an example of one version of Bayes' theorem, which this kind of problem has. So you might be asked about two possible situations and then asked about the probability of something that might apply in either case. Bayes' theorem version 1 is a good way to actually figure that out as well.
Print out those ones.
Yeah, so in terms of the length, it's going to look kind of like a practice test, so like 8 or 9. For you guys, probably 8. So yours is probably look more like the 8.9. My other class, we have a little bit longer session. I'll probably give them 9. But you guys, I'll give 8.
Is binomial probability on there a lot?
Oh yeah, for sure. Binomial is definitely there, but I'm not going to tell you it's binomial. I won't say, hey, this is binomial. So you do have to know how to recognize a binomial just from the problem itself, which means 3 things have to be fulfilled. You're repeating the same thing over and over. There are only 2 possibilities, success or failure, and each possibility is independent of the other. And then you can use binomial. So if I look at, say, practice test 2, just the first version. Everything's binomial.
Because number 4, that was the binomial before that.
Yeah.
You know what
Yeah, so on the version 1, problem 4 is a binomial. And you'll notice that I didn't actually mention that. That's the one about beer pong.
Can we do that one?
There's a beer pong problem.
Yeah, can we do that one? 'Cause
So that was binomial.
on the first test.
Practice version 1, problem 4. That one says, Jack loves beer pong. And he wins about 84% of the games he plays. In his freshman year at college, he plans to play 153 beer pong games. What is the probability that he will win 130 games? Yeah, so here it's like your n is 153 because he's very dedicated, he plans it out. And we know that the probability of success, the probability that he wins a game is 0.84. The probability that he loses a game, therefore, is 0.16. And we want to know, and if x is the number of games won, then you're asked for the probability that he will win 130. So that's a binomial. Because he's just doing the same thing over and over. He's playing bear pong over and over. That's his probability of success in the game, that's his probability of failure in the game, and you want to know what's the probability that he has successes 130 times. So that would just be 153 C 130.84 to the 130 and 0.16 to the 23. Yes, about that. So you know the probability of success, and it was a win-lose situation. You're either in one camp or the other camp. You want 130 successes, so that was binomial.
So the test will look like a lot like these practice tests. Like the same.
Are you gonna have a formula sheet at all?
No, not for this. So the formula sheet only is for financial math. So you'll have that formula sheet for the final, but not for this one. Yeah.
How long is the final exam?
That's like 2 hours. Yeah. So your final exam, it's pretty much like test 1 and test 2 stitched together. It's pretty much what the final is going to look like. So, yeah.
On test 1, can we go over number 6?
Yeah.
Oh, the students in Jhevon's class and Raymond's class?
Yeah.
Raymond's a friend of mine. We were adjuncts together at City College for a long time. And we often taught the same classes, and then we'd often talk about how our students were doing. It was ridiculous. Okay, so again, this is practice version 1. And this is problem 6. So you have the statistics for a group of students who took either Raymond's class or Jhevon's class. In Jhevon's class, 15% of students got A's. J is equal to student got A in Jhevon's class. So the probability that you got an A in Jhevon's class is 15%. And in Raymond's class, 12% got A's. $80% of students who took both of these classes got A's in both of the classes. Let J be the event you get an A, and thus R is that event. Okay, so A. J and R, are they independent?
Yes.
Reasoning.
Because you getting an A, you can get an A and a B, and it just doesn't matter. They're separate classes.
No.
Okay.
And if you do the P of A, P of A and B.
Remember what independent means. You want to check, is P of J and R equals to P of J times P of R? That's how you determine independence, not what makes sense to you. Right? What makes sense to your brain is often wrong. Let the numbers speak for themselves. So this we know is 0.18. This we know is 0.15. This we know is 0.12. Now if you multiply these two, do you get that? The answer is no, you do not get them. So therefore, they are not independent. According to the statistics you've been given, they're not independent. Let the equations speak for you. So, and like I said, nothing on my sleeve. I'm warning you. Like, I'll describe a situation where there'll be a reasoning, like there'll be some way for you to say, well, you know, it kind of depends on that one. But don't pay attention to the situation. Pay attention to the actual numbers being given. That's how you determine independence or not. So the answer is no, they're not independent because this times this is not that. B, are they mutually exclusive? Mutually exclusive means they cannot happen at the same time.
P of J and R is not equal to
Right. P of J and R, we are told, is 18%. That's not 0. So no, they're not mutually exclusive as well. We know mutually exclusive means and is, the probability of and is 0. Okay. And then part C. What is the probability a student will get, I don't know if I can fit the probability that a student will get an A in either Jhevon's class or Raymond's class. So this is asking for J or R. How do you find that?
P of A, P of B,
Right, you use that formula. P of J plus P of R minus P of J and R. Use the law of disjunction, formula that we got here. So P of J was 0.15, P of R was 0.12, and I'm going to subtract 0.18. So that would give you what? That's like 27 minus 18 gives you 9. So there's a 9% chance you'll get an A in either or. So yeah, so in fact, when I do say I'm going to ask you conceptual questions, it's never completely conceptual in the sense that, oh, you can just give me some kind of argument about why you feel this should be a certain way. It's testing your concept as to whether, do you know what the numbers I just gave you, what they mean? Right? So based on the numbers I gave you, what I just told you is not independent, it's not mutually exclusive, and one or the other happening is 9%. Yeah, so that's what that one. So yeah, in problem 1, that's just like the picking the ball out of a bucket. I think we're fine with that problem. And problem 2 was the constructing a probability distribution, like when you win money or lose money. Problem 3 is the Markov chain problem.
Can we go over that?
4 was the binomial. Hold on. 4 was the binomial. 5 is a Bayes theorem problem. 6 we just did. 7, that's just a regular probability problem. You just have to know how to count the number of cards in a deck and figure that out. And then, yeah, 8 is Bayes theorem version 1. So you should be able to recognize like what they are.
Could you do that one without using Bayes theorem, or do you want to?
You could, like usually when you can use Bayes theorem, there's a way to use a tree diagram or a table to do it also. So I'm not gonna be stuck, but I think Bayes theorem in terms of a formula, if you like formulas and plug and chug, just using Bayes theorem is the most straightforward way. There was someone who's asking me something.
I have to do number 3.
Yeah.
You said 8 was Bayes theorem, version 1.
8?
Yeah.
Which one did you say?
Yeah, Bayes theorem version 1.
Okay, thank you.
So that's going to be like, what is the probability it shows an even number? So then you're going to do, the probability of showing an even number is the probability of even given that I chose a regular die times the probability of choosing a regular die plus the probability of even given that I chose one of the weird dice times the probability of choosing a weird dice. So that's Bayes version 1. Is the schema that you would think about for problem 8. So problem 3, so let's go over that. So that's that's a Markov chain problem. And you will notice here also some interesting. So problem 3. Okay, a neighborhood has 2 rival cable companies. A retains 70% of its customer base, but loses 30% of its customer base to B. On the other hand, B loses 60% of its customers to A every year. Assuming this trend continues, what will companies A's market share be in the long run? So pretty much you can actually set up a Markov chain. So this is for A. Basically, here's the situation. I have 2 companies, A and B. And A retains 70% of its customers each year. So 70% of people will actually stick with A. While 30% of people will actually jump to provider B. B will lose 60%, so every year 60% of people who had B before will jump to A. And so it doesn't mention it here, but because we know that all arrows leaving a state must add up to 1, this is automatically means that 40% of people who have provider B will stay with provider B. So in other words, I can do a transition matrix here. A, B, A, B. So the people who starts with A and stays with A, that's 0.7. People who start with A and end with B, that's 0.3. People who start with B and jump to A, that's 0.6. People who start with B and stay at B is 0.4. And we know the initial state matrix. Oh, well, we don't know initial state. Here it asks for the long run. Right, so this is one of those questions. Once it says long run, that's asking for stationary matrices. Like if we keep just multiplying the transition matrix by state matrices over and over and over and over and over again, what is the state that this thing is going to head towards? So whenever it says after a long time, far into the future, if this continues indefinitely, if they say things like that, it's a Markov chain problem, and you want to actually find the stationary matrix. So I pretty much want x times y times 0.7, 0.3, 0.6, 0.4 to equal to x, y, which means 0.7x plus 0.6y must equal to x, which means if I move the x over, I get minus 0.3x plus 0.6y, and I'm going to use the fact that x plus y equals 1, which is always going to be true, and so I'm going to solve that system. Row 2 plus row 1, that would give me 0, 9, 3.
You have to write like when you switch them. You have to like indicate that.
You just indicated by you could write row 2 here. But at the end of the day, that tells you that 9y equals 3, which means that y is equal to a third, which automatically means that your x is 2/3. And so this means that in the long run, 2/3 of people will stick with company A, and 1/3 of people would stick with company B. So if it says, write it as a percentage with 2 decimal places. So this would be 66.67% will stay with A, and then 33.33% would stay with company B. So in the long run, if we pretend this happens, A will own 66% of the market, and B will own 33% of the market. Yeah.
When would you need to provide P-box?
For something like P bar, you'd be like directly asked for that.
Yeah.
Yeah.
And that would literally just be 2/3, 2/3.
Yeah, you just put 2/3, 1/3, 2/3. 1/3. Yeah.
And
I
is
do the
it,
expected value problem.
There's another part here. And it's the same situation, but then in part B, so this was part A. So this one's obviously one of the longer problems, but some of the problems are really short, like that binomial theorem problem was like super short, so it kind of balances out. So in part B, it's the same situation, but in part B, it gave you an initial state and asked you about after 2 years, which I'll probably ask you about after 1 year in the test. So it says, if A starts out controlling 55% of the market, what will its share be after 2 years? So this one tells you that the initial state is A has 55%. Well, that would obviously mean that B must have 45%, so that's the A and B in the initial. And so after 1 year, you want to find S2, which is going to be 0.55, 0.45 times 0.7, 0.3, 6.4. And then you would find S3, which is just going to be S2 times the P again. And ultimately, when you do these two multiplications, that's going to give you two numbers. And your answer is going to be in this location. So you just do two matrix multiplications. And I actually wrote down the answer, I think. 66.55. This was 66.55%. But you just do the row times column, you get an answer. It'll be a 2 by 2. You put it here, then do it again. And you'll get 66.55, and over there you'll get like 33.45. And so you get the answer for 8.
And you said we wouldn't be looking that far into the future, right? You said just a year or so?
Yeah, probably for you guys, I'll just ask you, next year, what do you expect to happen? Probably the other class, I'll ask them 2 years. they have like extra time. So my other class is 1 hour and 15 minutes long, so I can give them extra calculations.
What is a P-bar called again? Like what's the long name?
Long-term transition matrix.
Okay.
So the phrase transition matrix will be used. What is transition in the long run? Or what is the long-term transition matrix? Or something like that. I probably won't ask for that though, but definitely for the stationary matrix, the long-term state matrix, that's definitely something you should know how to do. This thing here.
Okay, S bars.
For sure. So I would go as I'd probably just ask you just the next year, so you do one matrix multiplication, and then I would throw in like one of those conceptual Markov chain problems, which is like problem 8 or 9, like what we practiced yesterday. Yeah.
This is about the final, but are you going to be giving us review for final, or will you say just using just review and review from the first last review?
I'll give you a review for the final. What I'll post for the review for the final is like my old final. I'll just post the final I gave last time. So I expect something like this.
And then the practice tests that you gave for this test are pretty representative of the test we'll be taking Friday.
Yeah. In fact, one of these was the test that I gave last time. So this was the test that I gave in fall 18, like a year ago. I gave this, was the exact test.
Okay, we do 12 on the random and
On the Okay, so something like that would be something you should know how to do. So this is like the choosing problem. So this is from the random test. So it says an urn contains 7 red balls and 7 red, and we have 5 white. You pick 2 in succession without replacement, so that's going to be important. Without replacement, choose 2. Because the with replacement and without replacement is going to be important. The without replacement means a conditional takes effect. The denominator of your probability is going to change. If the second ball is white, what is the probability that the first was white? So now this is says probability that given that the second is white, what is the probability that the first is white? So what do you think here? Well, in other words, that's probably choosing two whites. That's one way you can think about it. Another way you can think about it is, or you can do like a tree diagram for the choices. You could go white and then white or red, or you can go red and then white or red. So now what you know is that this happens. So what is the probability that the first thing happened was white? So that would mean it's the probability that a white happened first, then a white happened second. So that's going to be five. 5 out of how many total? 12. And then you have to multiply that by
4 over 11.
4 over 11. So that's the probability that you get a white first, then you get a white second.
Did you put it over something?
Well, you could simplify this. That's all I would do. So this is like 20 over 12 times 11 versus 2. Other than that. So you could also do that here. This probability would have been 5 over 12. Then this probability would have been 4 over 11.
But Jhevon, can you use a formula that's like P and probability of P and A and the probability of B conditional?
Yes, and it would actually be the same thing because this would be here. You could do that. You'll get the same thing. Yeah. So you could also use probability of A given B is the probability of A and B over the probability of B. You'll get the same
So what would
answer.
that redo it?
But this I would just think of it as choosing two. And there's another earn. There are a bunch of earn problems here.
It's like, how do you know when to like use that formula versus just doing like?
Oh, because the choosing one, we did a bunch of problems like this where you're picking balls from an urn. You normally just think of it that way. It's shorter.
Do we do the expected value?
Which one is that?
That's on the other, the original.
Number 2.
Yeah, number 2.
How many expected value problems are we gonna get?
Like one.
Okay. And it'll be just like 2.
Well, it'll be an expected value problem. I don't have to be just like two. So in 2, it asks about a deck of cards, and I ask you about another game. Well, you're playing a game where you're rolling dice. You're playing some other situation. So this is from practice 1, problem 2. You and your friend are playing cards and decide to make a bet. If your friend draws 2 aces in succession from a standard deck, without replacing the first card, you will give him $70. Otherwise, he has to pay you $10. Construct a probability distribution for your winnings. So let X equal winnings. There are two possibilities. You will either make $10 or you will lose $70. And you want the probability of each. So the probability that you will lose 70 is if your friend picks 2 aces. So this is going to be the probability of choosing 2 aces, where you're choosing without replacement. So what's that going to be? A couple ways you can actually think about that. There are 4 aces that he could pick, right? Out of 52. And after choosing that one, there are 3 left that he could pick out of 51. So this is just 12 out of 52 times 51. And then the answer you put here is 1 minus that. So those are all the possibilities. So again, this is kind of like the earn situation. You're choosing stuff without replacement. This is a nice way to think about it. Just say how many choices you have out of the total. Then of course you reduce the choices correspondingly, and then figure out how many choices you have now, and then now, and then now. And then you get this. So this is, that's how you'd set that up. Of course you'd like write this out nicely. What is this as a decimal? So we can have this. 12 divided by parentheses 52 times 51.
So it's 0.0045.
0045. It asks for 2 decimal places, so let's actually keep it in 4. So 1 minus that.
0.9954.
So I'll use, so that's the table. So this is called the probability distribution. So this here, probability distribution. So it's just a table that tells you how the probabilities are distributed over each case. And then it says, what is the expected value of your bet? So here you're going to find the expected value of the winnings. And so this is just x1 times p1 plus x2 times p2. So that's going to be 10 times 0.9954. Like 99% of the time you are going to win the $10, but minus 70 times 0.0045. Like 0.4% of the time you will actually lose 70. So how much do you expect?
$9.64.
So if your friend takes the bet, yeah, you should play this game with your friends.
964.
964.
Haven't taken probability. Just use your knowledge for evil. Hey, you took probability? Want to play a game? I'll give you $70 if you do this. You know what? If it doesn't work, give me 10. Yeah, you'd win most of the time on average. You make $9.
Your answer gave us about over 30 billion answers before the
For the random?
last row. So last
So that's the probability of the second was white versus white.